Hello, dear learners! Welcome to your mathematics class. I am teacher Yvonne and you are watching DepEd TV. Today, we will be discussing the 6 trigonometric ratios that will help you solve right triangles. Are you excited? Bring out your pen, paper, and self-learning module. Our learning objectives for today's lesson are: first, identify the 6 trigonometric ratios of an angle. And second, solve right triangle. Before we move further, take the pre-test to determine what you already know about the topic.
Direction. Answer the following questions pertaining to solving problems involving the 6 trigonometric ratios. You will be given 5 seconds to answer each question. 1. What do you call the branch of mathematics that deals with the relations between the sides and angles of a triangle? A. Algebra. B. Calculus. C. Geometry. D. Trigonometry. The correct answer is D. Trigonometry. 2. In a right triangle, what do you call the longest side? A. Leg. B. Hypotenuse. C. Longer leg. D. Opposite leg. The correct answer is B. Hypotenuse. 3. The trigonometric ratio of an angle's opposite leg and the hypotenuse of a right triangle. A. Sine. B. Cosine. C. Cotangent. D. Tangent. The correct answer is A. Sine. 4. The trigonometric ratio of the acute angle theta of a right triangle defined by a cosecant is A. Hypotenuse over opposite. B. Opposite over hypotenuse. C. Hypotenuse over adjacent. D. Adjacent over hypotenuse. The correct answer is A. Hypotenuse over opposite. 5. The 6 trigonometric ratios are only applicable to what kind of triangle? A. Acute triangle. B. Right triangle. C. Obtuse triangle. D. Equilateral triangle. The correct answer is B. Right triangle. This time, you may pause the video and answer items 6 to 15.
How was your score? Did you get all the items correctly? If not, don't worry. Take note of the items that you did not get right and find the correct answers as we go through this lesson. In your previous modules, you have learned about the parts of a given right triangle.
Let us have a review on the different parts of a right triangle. Suppose we have triangle ABC. A and B are the acute angles of the right triangle. A, B, and C are the sides of the right triangle. Here, we use the convention that angles are named using the capital letters or the uppercase letters, and the sides opposite the angles are named using the lowercase letters. The legs of the right triangle are A and B, and C is the hypotenuse. Trigonometry comes from two Greek words, trigonon, which means triangle, and metron, which means to measure. So basically, it is the branch of mathematics that deals with the relation between sides and angles of a triangle. It is important to identify the different parts of a right triangle, specifically the two legs in relation to an angle if opposite or adjacent. Let us have triangle ABC, for example. The adjacent side is the side next to the reference angle. Our reference angle here is B, or angle theta. So the side next to this angle is A. For the opposite side, this is the side across the reference angle. So since our reference angle here is B or angle theta, the side opposite this angle is B. For the hypotenuse, this is the longest side opposite the right angle. The right angle here is C. So the hypotenuse is C. How about if the reference angle is A? What will be the adjacent side? That will be B or segment AC. How about the opposite side? That's right. It will be A or segment CB. How about the hypotenuse? C or segment AB. Notice that the hypotenuse does not change. For the next activity, you are going to identify the adjacent side, opposite side, and the hypotenuse with respect to the reference angle. You can pause the video and answer the activity. Now, let's check your answers. If the reference angle is A, the adjacent side is B. Its opposite side is A. And the hypotenuse is C. If the reference angle is B, this is a reference angle. The adjacent side is A. The opposite side is B. And the hypotenuse is C. If the reference angle is X, we will use the second triangle. The adjacent side is Z. The opposite side is X, and the hypotenuse is Y. And lastly, if the reference angle is Z, the adjacent side is X, the opposite side is Z, and the hypotenuse is Y.
Were you able to identify the adjacent, opposite, and hypotenuse of the right triangles? I'm sure you did. Now, it's time for you to learn the 6 trigonometric ratios.
In a right triangle, we can actually define 6 trigonometric ratios. And for example, we have triangle ABC. We let angle B as our reference angle, and it is represented by angle theta. Now, the fundamental ratios are sine, cosine, and tangent. Each ratio have 3-letter abbreviations as shown in the second column. So for example, we have sine. Its abbreviation is SIN. And sine is the ratio of the opposite side and the hypotenuse. Cosine has an abbreviation of cos, and it is the ratio of the adjacent side over the hypotenuse. The third ratio is tangent theta, which has an abbreviation of tan, and the ratio of the sides opposite and the adjacent sides. Now, for the next 3 rows, notice that they are the reciprocals of the first 3 ratios respectively. So cosecant, which is abbreviated as CSC, is the reciprocal of sine. If you're going to look at the ratio of lengths, it will be hypotenuse over the opposite side, which is the reciprocal of the sine, which is opposite side over hypotenuse. Next, secant theta has an abbreviation of SEC. This is the reciprocal of cosine. So if we're going to look at the ratio of lengths, we have hypotenuse over adjacent side. And the last ratio is the cotangent theta, which has an abbreviation of cot or COT theta. This is the reciprocal of tangent theta, and this is the ratio of the adjacent side over the opposite side. To easily remember the equations, we use the mnemonic SOHCAHTOA and CHOSHAKAW. So these 9 letters are a memory aid to remember the ratios for the 3 fundamental functions and the reciprocals. So for example, we have SO. So here means sine, opposite, hypotenuse. Ka, cosine, adjacent, hypotenuse. And TOA means tangent, opposite, adjacent. And then the reciprocal ratios, which are the cosecant, secant, and cotangent. So CHO means cosecant, hypotenuse, opposite. SHA, secant, hypotenuse, adjacent. And then COW means cotangent, adjacent. Let's have an example. Given right triangle ABC, identify the 6 trigonometric ratios at angle A. So the first ratio is sine A. Remember that sine A is equal to the ratio of the opposite side and the hypotenuse. So this is our reference angle. Its opposite side is 3. And the hypotenuse is 5. Meaning, sine A would be equal to 3 over 5. Second, cosine A. Cosine is adjacent over hypotenuse. So, this is our reference angle. The adjacent side is B. And the hypotenuse is C. Meaning, our cosine A is equal to 4 over 5. Next, tangent A. Tangent is opposite over adjacent. So, opposite over adjacent. So, A over B, that would be equal to 3 over 4. For cosecant A, this is the reciprocal of sine. So, hypotenuse over opposite side, you can just get the reciprocal of sine. So, since this is 3 over 5, the reciprocal of 3 over 5 is 5 over 3. And then secant A. Secant is equal to hypotenuse over the adjacent side. So, C over B, the reciprocal of cosine, that is 5 over 4. And the last ratio is cotangent A, which is equal to the adjacent side over the opposite side. So, since this is the reciprocal of the tangent, we have 4 over 3. In triangle XYZ with y as right angle, find the other trigonometric ratios of x if sin x equals 12 over 13. Let us draw triangle XYZ first and label the parts basing from the given. Since the given ratio is sine, with x as the reference angle, we can say that this is the opposite side. And this is the hypotenuse. One leg and the hypotenuse is given. Therefore, we need to solve for the other leg, which is z. We can solve for z by using the Pythagorean theorem. We substitute x with 12 and y with 13. If we square 12, we get 144, and the square of 13 is 169. Transpose 144 to the other side of the equation. And then, subtract 169 and 144, we get 25. Get the square root of 25, we get 5. Since z is already solved, we can now write the remaining 5 trigonometric ratios. Sin x is equal to 12 over 13. Cosine x is equal to 5 over 13. Tangent x is equal to 5 over 12. Cosecant x is equal to 13 over 12. Secant x is equal to 13 over 5. And cotangent x is equal to 12 over 5.
Solving right triangle means finding the measures of the other angles and sides of a right triangle. In order to do this, you can apply the 6 trigonometric ratios you just learned. And to avoid committing errors, maximize the use of the given values of the parts of the triangle.
Solving a right triangle means determining the remaining sides and angles of a triangle. We can solve a right triangle given the following parts. First, hypotenuse and one leg. Second, hypotenuse and one acute angle. Third, one leg and one acute angle. And fourth, two legs. In solving right triangle, we use the fundamental trigonometric ratios sine, cosine, and tangent. Approximate symbol is used when the value is rounded off, and you need scientific calculator in answering the problems. Let us have the first example. Solve for x, y, and z using the triangle XYZ. Since angles x and z are complementary, we can write it as x plus z equals 90 degrees. And then substitute z with 25 degrees. Transpose 25 to the other side of the equation, so it becomes 90 minus 25. Subtracting 90 degrees and 25 degrees will result to 65 degrees. Number 2. Solve for v, I, and c using the triangle below. We are going to solve the missing side, which is the hypotenuse represented by v. And for us to know the value of v, we will use the Pythagorean theorem. The two legs of the right triangle are already given, so we are going to use c and I to represent the legs. Substitute c with 8 and I with 10. If we square 8, we get 64, and the square of 10 is 100. The sum of 64 and 100 is 164. Get the square root of 164, and that will give us 12 and 81 hundredths. Next, we will solve for angle I. Using the sides given, I is related to I and C by tangent. Why tangent? Using I as our reference angle, side I is the opposite side, and side C is the adjacent side. The trigonometric ratio, that is the ratio of opposite and adjacent, is tangent. We will now substitute O with 10 and A with 8. To get the value of angle I, we are going to use scientific calculators. Press Shift tan in the calculator and you will see tangent raised to negative 1. Then press 10 over 8. That will give us 51.34 degrees. This time we will solve for angle C. Tangent is used since the given sides are opposite and adjacent. We will write tangent C is equal to O over A. Substitute the opposite side with 8 and the adjacent side with 10. Again, we will use a scientific calculator. Press Shift tan and you will see tan raised to negative 1. Then press 8 over 10, then equals, and that will give us 38.66 degrees.
Are you now ready to solve right triangles? Let's now proceed to your practice activity.
Solve what is asked in the problem. Write your solutions and answers on your answer sheets. Check your answers using the answer key provided. A. In triangle ABC, find each trigonometric ratio if A is equal to 5, B is equal to 8, and C is equal to 11. B. In triangle MEN with E as right angle, find the other trigonometric ratios of M if tangent M equals 3 over 2. And letter C, solve for R, D, and E using triangle RED.
By this time, you already have the needed knowledge and skills in illustrating trigonometric ratios. Let's check what you have learned by answering the next activity.
Match the trigonometric ratio to its definition. Write the letter of your answer on the space provided before the number. Find B, A, and C, then determine the 6 trigonometric ratios of B.
Congratulations! You are almost done with your module. Let's evaluate your learnings by answering the assessment.
Direction. Answer the following questions pertaining to solving problems involving the 6 trigonometric ratios. You will be given 5 seconds to answer each question. 1. What do you call the branch of mathematics that deals with the relations between the sides and angles of a triangle? A. Algebra. B. Calculus. C. Geometry. D. Trigonometry. The correct answer is D. Trigonometry. 2. In a right triangle, what do you call the opposite side of the right angle? A. Leg. B. Hypotenuse. C. Longer leg. D. Opposite leg. The correct answer is B. Hypotenuse. 3. The trigonometric ratio of an adjacent leg and the hypotenuse of a right triangle. A. Sine. B. Cosine. C. Cotangent. D. Tangent. The correct answer is B. Cosine. 4. The trigonometric ratio of the acute angle theta of a right triangle defined by a cosine is A. Hypotenuse over opposite. B. Opposite over hypotenuse. C. Hypotenuse over adjacent. D. Adjacent over hypotenuse. The correct answer is D. Adjacent over hypotenuse. 5. The 6 trigonometric ratios are only applicable to what kind of triangle? A. Acute triangle. B. Right triangle. C. Obtuse triangle. D. Equilateral triangle. The correct answer is B. Right triangle. This time, you may pause the video and continue answering items 6 to 15.
This time, you use your scientific calculators in the additional activities. You did a great job finishing this module. See you in our next session. Bye! I would like to acknowledge Mr. Elmer A. Sakwog of SDO Baguio City, the developer of the self-learning module from which this video lesson is based.